Hello students! In this video, I would like to show you how to solve equations involving fractions. So we will start with the easiest example. In this equation on the left-hand side, we see a fraction expression. So to solve this, we are going to first remove the denominator. So there is this division by 5 here. So what we will do the inverse operation. So we are going to multiply both sides by 5. And because we know multiplying and dividing by 5 cancels out, so on the left-hand side of the equation, we will have 4y, and on the right-hand side of the equation, 20 times 5 is 100. And the last step we have to do is to isolate y, make y the subject, and here we have 4 times y, so the inverse operation is divided by 4. And when you do that, we will end up with y on the left-hand side, and 100 divided by 4 is 25. So therefore, we have solved the equation, and we figured out that the value of y should be 25. So that's not even so hard, right? So let's go and move on to the next example. So similarly, here, what we have is a fraction on the left-hand side, and we would like to remove this denominator. So canceling it out by multiplying both sides by 2. So this will cancel out, and we end up with 3 times in the bracket a plus 5. And on the right-hand side, 9 times 2 is 18. So here I'm going to show on the right-hand side a different kind of way, or the different kind of steps. Let me write down first. So the first step will be the same, multiplying out both sides by 2, and we will end up with 3 times a plus 5 equals 18. But from here, we will do it slightly differently. So on the left-hand side here, I'm going to try, okay, I have 3 times in the bracket a plus 5. So to remove or cancel out the 3 times, we are going to divide both sides by 3. And doing so give us a plus 5 equals 18 divided by 3 is 6. And we know that this one cancels out. And now what we have to do is to make a the subject by subtracting 5 both sides. And this will give us the result a equals 6 subtract 5 is 1. So we know that the value of a should be 1. So here on the right-hand side, I'm going to show slightly different things. Some people might think, oh, can I maybe multiply out the bracket first? That's okay. Remember distributive property, that when we multiply out the bracket, we will have 3a, 3 times a, plus 3 times 5, which is 15, equals 18. So if you actually do it this way, it will work as well, because now what we have to do is just remove or subtract 15 both sides. And doing so, we will end up with 3a equals 3. And then when you solve it, now divide by 3 both sides, we have a equals 1, which is exactly the same as on the left-hand side. So value of a is 1, solution is a equals 1. Now, in the next example, we can do this in different ways as well. So the first thing I will show you is that what we could do is we can, for instance, say, all right, can I maybe make it simpler on the left-hand side by adding 2 both sides? If I do so, adding 2 both sides, then on the left-hand side, I will have 2x over 3. And then on the right-hand side, I will have negative x and then plus 10. Now, because there is a fraction here on the left-hand side, then I know I need to multiply both sides by 3. So if I multiply both sides by 3 here on the right-hand side, though, you have to be careful because the whole right-hand side has to be multiplied by 3. So then I'm just going to put here, I'm going to multiply everything by 3. So in that case, on the left-hand side, I will end up with 2x. And on the right-hand side, don't forget distributive property. So I will have negative x times 3. So negative 3x. And then positive 10 times 3, which is positive or plus 30. Now, we have now x on both sides, and that is something we do not want. So how can we make sure that there is only one x on one side and a number on the other side? So what we could do now is to remove this minus 3x from the right-hand side. We are going to get rid of it by doing the inverse operation. So I need to add 3x both sides. And by adding 3x both sides, I will have 5x on the left-hand side and 30 on the right-hand side. Now the last step we will do will be to divide by 5 both sides, and the final answer in this case is then x equals 6. So here x equals 6 is the final result. You could actually also approach this problem in different way. So if I have, for instance, exactly the same question, but I would like to solve it in a different way. For instance, in this case, when I look at the left-hand side and I see this fraction, I know that somehow to remove the denominator, I have to multiply by 3. So what we will do, we are just going to multiply both sides by 3. Here you have to be a bit careful because there are 2 terms on the left-hand side. So we have to multiply all by 3. And the same thing on the right-hand side also there are 2 terms. So we are going to multiply all of them by 3. So in this case then, using the distributive property, we will have 3 times 2x over 3, and then minus 3 times 2. And on the right-hand side, we will have 3 times minus x, which is minus 3x, and then plus 3 times 8, which is 24. So in this case, now when I try to simplify, then I will have on the left-hand side 2x minus 6, and on the right-hand side then minus 3x plus 24. So what I could do now is to make sure that there is only x on one side and number on another side. So what we will do first now is to remove minus 3x from right-hand side. We will have to add 3x both sides. And from here, we will have 5x minus 6 and 24 on the right-hand side. Afterwards, we will add 6 both sides, which will give us 5x equals 30. And again, the last step will be divide both sides by 5. So the final answer is exactly the same as before. X equals 6. Now let's look at the last example. Here we have on both sides fractional expression, and the denominators are different. So on the left-hand side we have denominator 3, and on the right-hand side denominator 5. So what we can do, we are just going to do this step by step. So let's say we would like to remove this denominator 3 on the left hand side. What I have to do is to multiply this fraction by 3. And we will have to do that on the both sides. So what happened is, because we actually have 3 times a fraction, and 3 as a whole number we can always write as 3 over 1. And we know this will cancel out. So on the left hand side, what we have is basically just 4x plus 3 over 1, which means just 4x plus 3. And on the right hand side, again, I can think about this 3 whole number as 3 over 1. So meaning on the right hand side, I will have 6x plus 7 as numerator of the first fraction, multiplied by 3 as numerator of the second fraction. And the denominator, 5 times 1 is just 5. So this is what we will end up with on the right hand side. So now we are going to try and remove denominator 5 from the right hand side fraction. We will do that by multiplying both sides by 5. So we know that on the left hand side we also have to multiply by 5, but because left hand side has 2 terms, basically we are just going to multiply all together everything by 5. So in this case, again, this will cancel out. We know it already by now. So you will end up with, on the left hand side, 5 times in the bracket 5x plus 3, and using the distributive property, we should end up with 20x, 5 times 4x, and then plus 5 times 3, which is 15. And on the right hand side, we have 6x times 3, which is 18x, and 7 times 3, which is 21. Again, we have x on both sides, so we will try and remove from one side. So let's say I'm going to remove this 18x on the right hand side by subtracting 18x both sides. We will have 2x here plus 15 equals 21. And then next step will be to remove the number from the left hand side. We remove 15 by subtracting 15 both sides. So on the left hand side we will have 2x. And 21 subtract 15 is 6. And the last step, we will make x the subject by dividing by 2 both sides. So then in this case, we will have the final answer. Solving this equation for x will give us the value of x is 3 as the final answer. So as you see, although fractions always look complicated, it doesn't have to be difficult. So you can try and practice equations involving fractions in the worksheets. Good luck!